Hello, everybody. Welcome to Lowell Observatory's live stream of interactive stargazing tonight. We've got a pretty clear night here in Flagstaff. It's looking pretty good out here. My name is Brian. I'm an educator here at Lowell Observatory in Flagstaff, Arizona. I also go to school here at Northern Arizona University, where I study geology, astronomy, and physics. And right now, we've got our 14-inch plane wave telescope focused on the moon. The moon's just kind of rising here. So you'll notice when we're looking at it, using our Cam camera that's taking this image, we're getting a little bit of sort of waviness in our image. The scene isn't so good tonight, but there really aren't any clouds up. So we should be looking pretty good tonight for most of our objects. Full moon was last night, so we have a very bright moon tonight, and that'll make it somewhat difficult to see fainter things like galaxies, and some of our star clusters might be a little fainter than usual, but our Cam can push through that for the most part. So Daniel Mallets, like to see the Crab Nebula tonight. The Crab Nebula right now is kind of right next to the moon, pretty much in the sky. We're going to give it a shot here and see what it looks like. My fellow educators up at the observatory are freezing their butts off at the moment and going to be focusing our plane wave onto the Crab Nebula, or M1, and we'll see if that comes through. Just because of how close it is to the moon, it might be pretty washed out, but we'll see. Crab Nebula is an awesome object. It's a supernova remnant that was spotted. The light from the object reached us about 1,000 years ago, 1050. The object itself is, not mistaken, about 1,400 light years away. So it took that long for the light to reach us. But it was a massive star, many that reached, well, it sort of burned through all of its fuel point, exploded, and yeah, it is just not coming. We do have another supernova remnant in the sky right now. We could try the veil further away from the moon in the current sky. So it should be able to come through pretty decent. Okay, yeah, and Eugene Stemple, wondering if we can get a comet near Peg for it, maybe after the Veil Nebula here, and see if it shows up, although it may be too faint. We'll try. Yeah, so here's the Veil Nebula coming in. You'll notice the stars are really streaking across the sky, and that's because our Cam, or our plane wave telescope, just swept across the sky from near the horizon where the Crab Nebula was up to almost the complete opposite side of the sky for the Veil Nebula. So as we're taking these images, you'll see sort of streaking of light until it gets nice and focused in there. We can hold on for a second on our object. Yeah, so there's the Veil Nebula coming in a bit better there. You can see these streaks of gas throughout. And these are just leftovers from a massive star, probably 8 times the mass of our sun, maybe up to 15 times the mass of our sun, that reached the end of its fuel, reached the end of its life, and exploded. And now we've got this beautiful streak across our sky to look at. So yeah, there we go. Got the white balance in there. It's looking pretty good. When something bad like that's going to happen. Okay, it looks like we're maybe restarting our software here. Okay, we're good to go now. Having some technical difficulties. Okay, so we've got a request for M31. That's not mistaken, that is the Andromeda Galaxy, and that should be looking pretty good. With the moon being up, like I was saying earlier, these galaxies aren't going to look as good as they could sometimes, but M31 is sort of the closest galaxy to us, and it's a very large one. So if we're going to see a galaxy tonight, this one's probably going to be the best, or one of the best. There it is. So seeing that really bright ball in the center of the galaxy there, that's sort of the densest collection of the Andromeda Galaxy. This light, by the way, has taken like 2.5 million years to get here. That's how far away this galaxy is. It is our closest big neighbor as far as galaxies go, but despite that, it's still 2.5 million light years away. And whenever I'm asked, I always say this is my favorite object to look at in the whole universe, minus maybe a few things here on Earth. But yes, this is an awesome object, and it's actually the only galaxy that's coming at us out of a few 100 billion galaxies that we can see. This is the only one heading at us, which is sort of weird. Like you would think just statistically, there's say 200 billion galaxies, maybe 100 billion would be coming at us and 100 billion would be going away. But turns out this is the only one coming at us because the universe itself is expanding. It's sort of being pulled apart due to something we call dark energy, which we don't know a whole lot about, but it's a fascinating field and right on the cutting edge of astrophysics. Actually, about 100 years ago, there was an astronomer here at Lowell Observatory named Vesto Slipher who studied these galaxies. At the time, they were called spiral nebulae because galaxies hadn't really been confirmed. No one had thought of the idea of another galaxy separate from our own Milky Way. But he was studying these galaxies and noticed that every single one of them, except for this one, was redshifted in spectrum through his spectroscopy work. And the Andromeda Galaxy here was blue shifted, which indicated that it was coming at us and everything else was going away and sort of just pulling apart all the galaxies away from each other. So it's a fascinating object. We're looking at the combined light of about 1 trillion stars right here. And that's a few times bigger than our own Milky Way galaxy, which is already pretty big. So I think we ought to move on maybe from the Andromeda Galaxy. Let's switch it up a little bit. Let's go to the Owl cluster, if you wouldn't mind there, guys. So we went pretty much straight to looking at something that's outside of our own galaxy. And now I'm going to bring it back a little bit closer to a star cluster called the Owl cluster. And probably my personal favorite cluster. And hopefully you'll get to see why. It's a really neat one. In this case, it's a cluster of about 150 stars that are all sort of in a family, born together, all the same age, more or less. And together they're moving throughout our galaxy, trying to find sort of a stable place to orbit as time goes on. And as we switch objects here, the exposure times are going to need to change a bit. So if you're wondering what all is going on your screen, we have a couple programs up. One of them tells the telescope where to point, and the other is our Malincam software. That's sort of our camera that's attached to the base of the telescope. We can tell it how many seconds to leave the shutter open, basically, so we can gather as much light as we need. If something's dimmer, we need more light. Something like this, we don't need quite so much because there's a lot of little bright stars in here. And so yeah, this is the Owl cluster. You can see those two really bright stars toward the top left that they're pointing at there. Those are sort of the eyes of the owl, and down toward the bottom right is the body of the owl, as some astronomers saw it, and as I like to picture it. And there's some wings sort of outstretched to the sides as well. So that's a nice, what's called an open cluster. Yeah, so good point there. Hubble used Besto Slifer's data here from Lowell to really confirm that the universe was expanding and help establish that galaxies are a thing, and not just spiral nebulae, not just clouds within our own galaxy, though there's plenty of those, but there are actually all these galaxies completely separate from our own Milky Way as well. So yes, Hubble did really confirm that, but he used Besto Slifer's data, and that was some of the very first evidence that the universe was expanding. Okay, let's try another cluster. Maybe go to M37. So like the Owl cluster, this is an open star cluster, which is these families of stars, typically a few hundred stars in these families, and sort of all born together and moving throughout our galaxy together. This one, though, is not just a white screen, I promise. You'll see here in a second as we adjust the exposure. There it is. So this is M37, or Messier 37. There was a French astronomer in the 1700s named Charles Messier who cataloged about 100 objects that distinctly weren't comets, but he wanted to find comets. And so he was sort of labeling the things that looked fuzzy, comet-like, but weren't comets. And so this is the 37th one. And the more colloquial name for this is the Salt and Pepper cluster. Sort of looks like some salt and pepper sprayed out on a table. Let's see. So we've got some requests in the chat. Jose wants to look at Mars. That would be a good choice for sure. Mars is nice and bright in the sky right now. Pretty much most places in the world right now, especially here in Flagstaff, we're getting a great view of Mars. We were recently at opposition, which was sort of full Mars. Just like we have a full moon, when Mars is on the opposite side of Earth from where the sun is, it will be fully illuminated, and we get a nice full bright picture of Mars. That also is no coincidence, the closest approach of Mars to here on Earth. And so we get a nice view of it, and there he is. So this is the next planet out from the sun after Earth, fourth planet from the sun. And it's mostly just a barren, rocky, dusty ball. And if you ever wondered what the red color of Mars is about, it's essentially rust. It's iron oxidized. And the rocks there that make up Mars are sort of more or less similar to what you'd see if you go to like Sedona and you see all these red rocks around. So nice red planet for us, named after the Roman god of war. Mars also is only about half the diameter of Earth, which turns out may be a big part of the reason why there's no longer water there and why it's just so barren and dusty. We're now finding out with these rovers and things that we're sending to Mars that there's almost certainly water there in Mars's distant past. But Mars, being about half the width of Earth, only has about 1/8 of the volume And what that means is over time, the sort of hot core of Mars, just like we have here on Earth, would have cooled off relatively quickly because it's a smaller hot ball. Here on Earth, Earth is slowly cooling down, but Mars did so quite a bit quicker. And Mars, actually, you don't know, is pretty much the reason this observatory exists. Percival Lowell, back in 1894, decided to come out here to Arizona, get away from all the city lights on the East Coast where he was from, and set up an observatory where he could get nice, clear viewing of the red planet. And he did so because he was trying to prove that there were Martians there. He and some other astronomers had noticed that Mars has these sort of dark streaks across its surface. And he thought, and some other astronomers thought, that those were sort of canals. And that leads to the idea that perhaps there were an intelligent civilization there on Mars building canals for the purpose of transporting water from the ice caps of Mars down to the equator. And so, yeah, he was trying to prove there were Martians. Now, of course, we have better technology. We've been to Mars. We know that there's no water there currently, at least not on the surface. And those canals were mostly ancient lava flows, and they just look like dark streaks across the surface. So probably enough about Mars. We can move on. So request from Anwar Almala, the Dumbbell Nebula. Yeah, we should be able to see the Dumbbell Nebula. Let's head on over there. This is a somewhat fainter object, so we'll see if the moon is not washing it out. But I think we ought to be able to get it in there. This is one of my favorite objects to look at, especially through these plane wave telescopes where we have these cameras attached. We can take nice long exposures and see all these colors in a nebula like this. And this is what's called a planetary nebula. Doesn't really have anything to do with planets, but when they were first being discovered, astronomers thought they're sort of round. They look more or less like planets. So we'll just throw the name planetary nebula in there, and it's just sort of stuck. But what they really are stars roughly the size of the sun, so sort of medium to smaller stars that burn through their fuel. And as they do that, they sort of expand and expand and expand to the point that they can't hold on to those outer layers anymore, and they just poof out into space. And that's what we're left looking at. And you'll notice right at the center of the nebula, the little white star there called a white dwarf. That's sort of the burning ember that's left over from the star that was originally brighter and quite a bit bigger. And all those gases moving away are being ionized by the light that comes from that white dwarf. And so you've got probably mostly hydrogens on the red part of the nebula on the edges, and some heavier elements, maybe some oxygen and things like that, for the green and blue parts of the nebula. Okay. Helix Nebula, I'm being told we can't see right now. Sorry about that. And Book Davies, yes, we will be doing shows for the Great Conjunction. We're doing programs all throughout December, where we're going to be showing off that Jupiter and Saturn are sort of getting really close to each other in the sky, to the point that we'll be able to see both of them at the same time through telescopes. That should be pretty awesome. So if you're in or around Flagstaff, try to make it a point to come up here for that. Should be pretty fun. Okay, what else we got here? All an attack in Orion's Belt. I'm not familiar with that, is that something we can bring up? We do have Orion rising right now, so we'll be within view. Cool. So there we go. We've got on attack. That looked like sort of the, what would it be, the easternmost star of Orion's Belt. And Bellatrix as well from Ayla Wood would like to see Bellatrix, another star in Orion. And yep, we'll just hop right on over there and get a look at that. There we go. Orion's got some of the brightest stars in the sky. That's why it's such a prominent constellation. You've heard of Betelgeuse or Rigel. Those are some of the biggest and brightest stars around, and some interesting ones. They're sort of candidates for what may become supernova at some point, similar to the Crab Nebula or the Veil Nebula. Okay, the Running Man Nebula, John, looks like we won't be able to get it. It's too close to the moon tonight. So yeah, we're not going to be able to look at the Running Man Nebula tonight, unfortunately. If you have any requests, we can, other than Jupiter and Saturn, unfortunately, those are set at this point here in Flagstaff. They're only visible for a couple hours after sunset here, unfortunately. But if you have any further requests, we can definitely get to them next week with our next interactive stargazing session. Yeah, so let's go to Uranus while we still have a minute, and then we'll finish up, I think, with the Orion Nebula. Once that's sort of been rising a little bit, should be able to get a view of that. But while we're here, let's look at Uranus. I know my dad's in here, and he'd be disappointed if I hadn't looked at Uranus, because he always likes to make a joke about that. So there we go. That is the 7th planet from the sun. We're looking about 2 billion miles away. So a little underwhelming, this dot in the sky, but that is actually a planet a few times bigger than Earth as far as the diameter goes. And it's mostly helium with some water ice and methane and ammonia and things like that. But yeah, there's Uranus. And you might notice, not so much with Uranus because you can't see it without a telescope, but when you see planets in the sky, they don't twinkle at all. And that's because they have a little bit of width to them, right? They get sort of knocked around, or stars rather, which don't have width to them. The light from stars distantly will come into Earth's atmosphere and get sort of knocked around and twinkle. Whereas planets so much closer to us, only 2 billion miles away, compared to light years away, have that width. And when that light comes into our atmosphere, it does still get knocked around, but because of the width of it, it just doesn't twinkle like stars do. So if you ever want to know what's a star, what's a planet, when you look up at the sky, look for that twinkle or the lack thereof. Okay, and I think we only have a few minutes here, so I think we ought to finish up with the Orion Nebula. Couldn't leave tonight without giving the Orion Nebula a good try. The finest objects in all the sky is a stellar nursery. It's a cloud of gas that is currently forming stars, a bunch of baby stars in there. And we're seeing just a few of them there with this short exposure, and as we ramp that up,